I hope you still have some energy after a lot of great talks and being the last lot on the day. I'm going to try to make it entertaining, and hopefully maybe you don't fall asleep. But let's start properly with an introduction of myself. So my name is Marcel, and as most of you, I'm an Android developer. I've been working on Android for more than a decade. I was part of the Android DevRel team at Google, but this year I took a little bit of a different path, and I went solo. And I started exploring some AI, so some Android apps powered with AI. And then I even decided to go and found my own app development studio that basically, it's called PB Studio. And it's a hub of mobile experts. And we provide from technical consulting to end-to-end development. But today, I'm here to share a little bit about my experience of these last months integrating AI into Android. All right. So, artificial intelligence. Fancy image, right? I'm not going to go deep into what is AI, and I'm by far no expert on this subject. I'm sure there are other more experts around the room. So I'm going to focus on this talk specifically on generative AI, and more specifically, how you can integrate that into your application safely. But let's do a quick introduction of what generative AI is. So generative AI is the base technique that learns data from existing artifacts and uses to generate new artifacts. On top of this, there are what they call the foundation models. Those are a class of AI models that are pre-trained with a lot of data, right, across various domains, enabling them to develop a wide range of capabilities, from language processing to video to audio recognition and all that. Then on top of this, there are the large language models, or LLM. Those are the ones that probably you have heard about it, right? With GPT and Gemini and so on, right? Those are like models that are done to process a language. And so general purpose language generation and other tasks like classification of language and so on. And then on top is what it's more used, that is the user interface with the chatbots or the APIs, or what we are going to use for our app. Okay? This is an oversimplification of all that. So this new technology has opened a wall of new possibilities. We can reimagine existing use cases and find new ones. That being said, there is probably a little bit of hype around that. How many here tried to use OpenAI or Gemini SDK in your application, or your company said, we need to introduce AI into our app? Hence? Yeah, right? So, there is no doubt that there is a hype about it, right? And probably we have not even reached that peak. If you're familiar with this graph, you know what I mean, right? We are now trying to find what is useful, what it makes sense. Apps and companies are integrating there, like, let's just put AI and see what it comes with. So we need to really find what is this curve of slope of entitlement till we reach the plateau of productivity. Hype aside, I do believe the AI is here to stay, and we really need to start learning and see how we can integrate that into our applications. So let's dive in and join this hype. Let me share you a secret. I have an idea. Let's build an app that, given any message from any other application, you can share it with the app. Then the app generates a reply based on your preferences, like tone, format, and so on. It copies it on the clipboard, and then go back to the application, and they can reply automatically. I'm going to make millions. All right. So let's use Gemini SDK to implement this. Let's check the docs. By the way, you could use OpenAI or Mistral or any other APIs out there, right? I'm just going to focus on Gemini, but the same concepts would apply. So first, get the API key. That is easy now, but before, if you were in Europe, you had to use VPN because Google did not allow you to use that here in Europe, but now you can get the key. And then it tells us to secure the API key using build config and Gradle secrets plugin. Maybe we rather call this hardcode the key. And I have to say, since I created these slides, I saw that they updated and they add this nice banner saying like, just use this for prototyping. And you will see why later. All right. We create the client, pretty straightforward, right? We just call this a generative model. We pass our API key. We define the model that we want to use. And then we just need to generate the response with the prompt, and that's it. All right, let's dive into that. It's quite straightforward. Don't judge my code, it's a simplification. Let's create a simple screen, right? We get the clipboard manager, where we get the text that was shared with our application, and then we create the Gemini model using our hardcode key, and we define the model name that we want to use. Then it's simply, we just launch this effect that basically we will create our custom prompt. Here's where you become a prompt engineer, and you just call the SDK and get the result. We pass that back to the UI and to the clipboard, and that's it, right? So I think the MVP is ready. We share it with the app. It generates some answer. It copies into the clipboard. We go back to the app, and we just can directly share it. They're going to pay me so much money for that, you will see. I think it's ready. Do you think so? Let's ship it? Let's ship it. All right, let's see. First users are coming in. The AI costs are OK. Oops. What happened here? Yeah. So what happened here is that most likely our API key was stolen, right? Even if you use obfuscation, there are easy ways to revert the software out there and find your API key that you stored in your APK. It's as simple. You download the APK from the Play Store, from other places. Then you use the Android Studio itself. There are other softwares there as well. But just with the Android Studio, it's super simple. You say analyze the APK, and then right there, in plain text, is your API key. So anyone can take it and use your credits, so you pay for it. So now what? Your best option? You just delete the API key, so it stops draining your money, but then your users are not able to use your application. You have to go through the Play Store update. We know how much time that can take. And then you need to improve the security, right? I present you the bad way of integrating AI in Android. All right, let's improve this. So there are a few techniques we could apply to avoid our key being stolen. So first of all, obfuscation, right? That normally actually already happens when you release an Android app, right? You enable like a pro word and so on, and the obfuscation mechanism will change the class names and the method names, the variables, and so on. But you know what? The string content remains intact. That is not obfuscated. So you're just making it a bit more difficult for someone that is analyzing your APK to find the key, but the content of the key is still there in plain text. We could apply our own obfuscation, right? So we can take our key, we do a base64 encoding, or we add some more custom logic into it. But this custom logic that you are applying, it's going to be in your APK, because you need to decrypt it before you pass it to the SDK, right? So whoever is looking at your code can find that out as well. So that's not good. You can use some native code, right? You create a C file, and then you put your key there and so on. But you're just making it a little bit difficult to the attacker. It still can't find your key easily. I want to highlight there are some paying services there that can obfuscate your code on a more like enterprise-grade type of things. Makes it way more difficult, but I'm stingy and I don't want to pay for that. All right, so of course, we could apply encryption, right? But we would encrypt our key, we would store it in our code, and then we need to decrypt it. Where do we store the key to decrypt it? Again, in our source code? Yeah, we are back to square zero, right? So we just probably make it a little bit more complex for the attacker, but they can still find the key. Super easy. All right, So what's clear here is that our key cannot be in our source code. That is the main problem first, right? So let's push it into a remote server somewhere. So basically, before we want to use the Gemini SDK or any other API endpoint for LLMs, we just fetch our key from the server, and then we pass it to the SDK, and then we can do the queries and so on, right? That sounds simple enough. I think I'm ready to ship it again. You think so? Come on. Yeah. All right. So let's see. Okay, that first day is a disaster. Cost me a lot of money, but since I fix it, oops. Yeah. I present you the ugly way of implementing AI in Android. So what happened? Again, the API key was stolen, right? And you think, but how? It's on the remote server. Well, you know, our attacker just could have see our source code, see that we are calling an endpoint, go to that endpoint, and make the same request we are doing, right? Impersonating our application and just get the key, and that's it. It's the same. Just put the things together, and he has it again. So how can we prevent this? We can add another layer here that requires some sort of authentication on the device to be able to fetch our remote. So then the attacker cannot just fetch the key. It needs to authenticate first from a real user and on our device, and then it can fetch the key again, right? So flow would be as simple as you encrypt your API key, you obfuscate the key on the public code, then you authenticate the app user. It then fetches the remote, returning the API key encrypted. You decrypt it locally. Now you can use the Gemini SDK locally. Yeah? So easy way to do it. Just again, some pro words. You can use the Jetpack security cryptor here to decrypt the keys. You just choose your encryption algorithm. By the way, this is deprecated now, since I did these slides. But you know, deprecated sometimes means stable. So up to you. Firebase authentication is an option, right, for authentication. And then you can have some remote config or Firestore to store your key. So you fetch it and you can use the Firebase rules to avoid anyone accessing that endpoint unless they are authenticated and are from your application. All right, but there is still an issue here. So what happened if the bad actor moves between? Right? There are software out there that allows to intercept network requests. The bad actor could intercept both keys, the ones that store on the remote server and the encryption key and so on, and do again the decryption. There are ways to protect around that. But what is if the bad actor is actually in the device itself? There are programs out there that allow to analyze code at runtime, add breakpoints, and check what's on memory. So some examples would be Frida, MobSF, or IDA Pro. This is the one that is showing here is a commercial disassembler that can be used to analyze disassembled code for Android apps, providing detailed information about function calls, memory usage, or other low-level details. So here's an example of IDA stopping on the disassembled code while your application is running and checking exactly what's in memory. So what happened? We did all this nice infrastructure to connect with our remote database, get the key, and so on. And the moment we are passing the decrypted key into the Gemini SDK, they can just see it because they stopped the code there. So what can we really do? We should make sure that we only execute our code on trusted devices. For example, with app check using attestation. I couldn't explain this better than this video, so I'm just going to play the video so I as well can drink some water. Is there sound?
Navigate home.
Sorry?
When users use your app, lots is happening under the hood. For example, this game is saving all its game state to Cloud Firestore. This app is using the Google Maps API to help someone navigate home. And this app is calling APIs on its own server. All those services on the internet waiting for any request that comes in. But that means it's also possible for someone who's not using your app to try to make requests to those backends. How can we prevent people who are not using your legitimate app from accessing your backend services? After all, usage costs money, and no one wants to pay for illegitimate usage. This is where AppCheck comes in. AppCheck will block traffic that comes from sources other than your app. If you have security rules, AppCheck blocks the traffic before it even gets to your security rules. To use AppCheck, all you have to do is register your app in the Firebase console, and then start enforcing that traffic that doesn't pass will be blocked. For this to work, AppCheck needs to be able to check that a request comes from your genuine app, not from some stranger trying to snoop around. AppCheck does this by using something called attestation services. These already exist for iOS and Android and the web. You can even build your own attestation services if you need to. AppCheck wraps all these services and makes them easy to use with our own SDKs. Now you can protect yourself and your app from anyone who might want to poke around at your app's backend. Firebase AppCheck can protect 3 different kinds of backends. Firebase backends, like Cloud Firestore, the real-time database, or cloud storage for Firebase, Google API services like Cloud Run or Apigee, and your API endpoints on your own server. Check out AppCheck today.
All right, so after this fancy video, as you can see, AppCheck, as much as it's a Firebase product, you can as well use just the attestation service by yourself, but they do all for you, but it allows as well to use your own server, so you're not tied to Google products or Firebase, right? It's quite nice. So what happens here is that basically our bad actor will try to make requests, and because most likely they have to root the device or they have to do some tweaking on the API in order to use this disassembler code to check the runtime and so on, the attestation will fail and will say, no, you're not the right trusted device, I reject you. So they will not be able to reach our remote to get our API keys. That being said, as you know, nothing is fully secure, right? And the key could go somehow into the client, manage on a way to get it. So a better way, I would say, it's use a proxy server. Instead of directly using the OpenAI or the Gemini SDK endpoints, let's use our own server, where our key is stored securely, right? There are like plenty of services out there to do that correctly on the server. And then the app just passes the request to the proxy, then the proxy just forwards it to the right endpoints. The key won't be exposed, and AppCheck will still validate that it comes from a trusted device. So it's quite nice. A nice way here we could use is just Firebase functions, right? It's nicely integrated with, for example, with the AppCheck, and we can use it as a proxy server. We can then ensure that there is auth, the AppCheck validates. We can control the prompt. So instead of just forwarding the prompt to the service, we could just pass data to our function and then do the prompt engineering into the Firebase function itself. And then use different fallback mechanisms. OpenAI is down, let's use Gemini or Mistral or any other AI services that they are there. We can as well do some pre or post-processing with Firebase Store, right? We could store like the prompts there instead, or we can fetch some data from the user, etc. Let's quickly implement it in our application. So after you successfully set up your project in Firebase console, this is the part that takes a little bit because you have to go for on the Apple, then you have to go on the Play Store and do it. But after you've done that, code-wise is as simple as this. You just install the AppCheck provider, and we are going to use the Play integrity here. And then instead of using directly the Gemini SDK, we are going to create our own function that goes into the Firebase functions. It's pretty straightforward, the SDK. You basically define a name of the function that you want to call, and you pass the parameters, and you wait for the reply. Then the SDK will automatically use the AppCheck token to validate that it's a trusted device or not. We'll call our Firebase function. Note that you need to manually enable that it does the AppCheck, right? So if the device is a not trusted device, our function will never be called, and we will not be charged for those calls either. So that's nice. And then here you have the full power of the Firebase admin SDK, where you can check, for example, is the user authenticated? You can check the custom claims of authenticating object. For example, you can check if the user is a pro user or if it has enough tokens, right? You can do all this processing here instead of the client, where you could cheat. Then we get the request data, and we can validate as well that the data is valid, that they are not trying to do some weird injection and so on. And then we use any of the tools to do the actual calling to the AI services. Here we can have fallback mechanism, we can have error handling and all this stuff. So yeah, exactly. So you can then check the different ones. The great thing of bringing the logic into our server is that we can have access to great tools to do AI engineering, like Instructor, for example. That makes it easy to switch between different models in a single interface. So you don't have to implement all that. You just say which model it uses and has a generic interface and can reach all the different models. It also applies type safety, so you can ask the AI to reply in a specific format or schema, and so on. There is another toolkit as well. It's quite nice. It's called Marvin. This is quite powerful, and it provides something like Marvin functions, where it kind of lets you combine the input instructions, so the contract of your function, together with like the Java docs, and that passes to the AI and to generate, to use the function for you. So you don't actually have to code anything. So for example, here, you would pass a prompt, and then it will return you a sentiment based on the instruction you put on the function. But again, you did not write the sentiment function. You just explain what it does, and then the AI does it for you. Or a new addition that was announced at Google I/O, that is Firebase GenKit. I have to say, Google did a great thing on this framework. And I don't want to sound like a Google fanboy, but I have to congratulate on this one. First of all, because it's, oops, I went too fast. First of all, because it's open source. It supports many models. So you're not tied to the Gemini models and the Google. So it can be extended to support any models, and there is a community already like building those extensions for you. It allows you to define strong type data, forcing the model to reply how you want. Instead of just getting like a bunch of text, you can say, no, you should reply with this create schema, create your schema thing, and it will reply on that way. You can create as well functions that the AI can execute. For example, here we create a function that it search nodes and then goes into our own database and search based on the query. Then we pass this to the prompt, and then the AI will use this function if it needs to query stuff. And as well, it's easy to manage and tweak prompts. They follow a standard format called .prompt formats, and you can test models and prompts locally. You can inspect the traces, and you can really like do testing around the AI and prompts, and not just hope that the AI will reply with the expected data all the time. There is much more, so it's quite promising. And if you're already using the Firebase ecosystem, it integrates really nicely. But if not, again, it's open source, so you can even use it in your own backends and so on. In any case, let's get back to our code. No matter what you do in the function, we just return like our generated text to the app. Then the app receives the results, copies to the clipboard, and displays to the user. I think we are ready to ship now again. Shall we? Yeah? All right. Okay. Please, please, please. I don't have more money. I hope this works. Okay. Yes. I think we finally managed. Now our API key was not stolen. And this is what I call the good way of integrating AI in Android. But this looks more complex than the initial example you show us. Yeah, indeed. But if you're planning to only use Gemini, you're in the luck. Since I created these slides, Google as well released something called Vertex AI for Firebase. So this is a new SDK. It's not the same as the Google AI client or Gemini SDK. It's called Vertex AI for Firebase. You know, naming is hard, and Google likes to mess up with that. All right. Oh, and there's a new logo for Firebase. Anyway, the interesting point here is that Firebase acts as a proxy, right? So all this setup that I showed you before, you don't have to do it anymore. So you use directly and your client, the Vertex AI SDK, and Firebase will do the rest for you. Will communicate with Vertex AI, where you can have as well there like prompts, your own models, and stuff like that, right? So if I go back to our initial implementation with the Gemini SDK, we just need to modify it a tiny bit. So basically, we just remove that and put the Vertex AI generative model class instead. And then the rest is actually the same as before. The generate content as well is a function part of the Vertex AI, so nothing changes here. And we have implemented securely with the same code I showed you at the really beginning, because Firebase does the heavy lifting here. There's an important thing to note, though. The app check is not enabled by default. You still need to integrate that. But as I show you, it's quite simple. And as any Firebase product, when you integrate app check into your application, you don't need to do any specific for each of the SDKs of Firebase you use. It will enable out of the box, right? All right. So in a nutshell, there are three main ways to integrate AI in our service. The good way, that is what I show you, uses obfuscation, encryption, authentication, and or device check. Getting secret from remote service, or even better, using a proxy server. That is what I believe is the best way. So you push all this logic from the client into the server. There is the bad way, of course, where you store the key in your source code, maybe use some obfuscation, and yeah, that's probably not a good idea. Or the ugly way, probably we could rename it to the not so good or not so bad, because it has some protection, right? With obfuscation, you add some hoops, so most likely the attacker will give up before that unless they are really aiming at you. So should you always use the good way? Well, not necessarily, right? There might be reasons to use any of those. But it's important to know the pros and cons of each of those. So with a good way, as you saw, the key never reaches the client, right? If you use a proxy server or something like this, it avoids unauthorized usage. It's easy to change the prompts because you have the control on the server, so you can change to different testing on the prompts and so on. But of course, it has an increase of time because you are doing some hoops on the request. It might get costly because then you have to add your own server cost plus whatever AI is charging you. And it might be hard to implement, for example, streaming AI reply. So instead of just getting the full reply, you get like chunks by chunks, because then you would need to do this unless you use the new Vertex AI for Firebase, where everything is integrated for you and so on. The bad way, I would completely discourage this unless it's really just playing around and doing a prototype. So Google did good to put that banner on the docs saying like just use that as a prototyping, because it's really, really easy to hack it and to find the key there, right? On the other hand, it's like simple to implement, but yeah. Or the ugly or not so bad way, where it might be a good compromise, right, between like doing all that implementation or having something that is more or less secure that allows you to ship fast, and then maybe later on you will have a better implementation there. All right, so just some final recommendations based on my experience around this. It's, first of all, always use app check or similar mechanisms, right? This is not only specific for AI, APIs and so on. It applies to any other keys or something that you would use. It's better to only run your code when it's in a trusted device. Never ever store in the version control. I see some of you have done that for sure. Prefer a proxy, so as well there are some key management service that you can share keys between your teammates so you don't have to store it on the source control. Prefer a proxy server to local keys. Again, if your keys never reaches the client, this is way more secure. Nothing is secure, but it's much better than having it on the client. Whatever mechanism, do not store unencrypted keys in your device storage. This is really easy to hack on a rooted device. So don't store that on the preferences and so on. And if you import keys into your application, there are things like secure hardware there. For example, for there's something called key store that allows you to import the keys without reaching the memory. So if we use IDE Pro or programs like that, they will not be able to see that on the memory. They have some mechanism there. And whenever possible, set hard limits to your API key usages. Sometimes it's not possible, but if it's better do that to make sure that you are not paying a lot of money. Okay, last words, there is no silver bullet. I think you all know that, right? When we talk about security. So probably we could just rename this to the hard, the easy, and the not so easy to hack. All right. And with this, I end the presentation, and I will be happy to take some questions. Thank you very much.